Hornet. My name is Sam LaMonica, Chairman of the Board of Trustees here at the USS Hornet, and on behalf of the entire USS Hornet family, we welcome you here, and we're delighted to have a great keynote speaker today and a great panel, and we hope you enjoy it. So today I have the wonderful opportunity to announce and bring on stage our keynote speaker, Lee Steinke. Lee Steinke is a scientist, a space industry executive, and a keynote speaker. Her company, Cislunar Industries, has contracts with NASA, the United States Space Force, DARPA, and others. During her career, Lee has worked on Earth-based and space-based projects in energy, power, and natural resource development. She has also been on the front lines in the advancement of in-space recycling, manufacturing, and materials processing. In her work on national security, she has also led various futures exercises and consulted on workforce development programs for both children and adults. Lee serves on a handful of advisory and review boards, is well published in technical topics, and has been featured on the TEDx stage. She holds degrees from Wharton, Yale, and the University of North Carolina, Chapel Hill, and attended the U.S. Army War College National Security Seminar. So it is my honor and privilege to welcome to our stage here on the USS Hornet, Lee Steinke.
All right, I'm going to take their microphone here. All right, so what do you want to be when you grow up? We keep asking ourselves that question well into adulthood. I grew up to be a time traveler. Yep, I get paid to travel through time. So as a space industry executive, I spend a lot of my time in the future, envisioning it, thinking about what its problems are going to be, and then I get to work on solving those problems with people like the ones I'm going to bring up to the stage a little bit later. My company, as Sam mentioned, we have space electronics for today's operations, but we also develop future technologies for recycling metals in space and refining metals from rocks on the moon and other celestial bodies. And in order to create that future that we're envisioning, we find it useful to visit the past as well. So what I want to do today is take you on two little journeys through time with me, and they're going to help you see how you can use the past to understand the present and to shape the future. And each of those journeys is going to make a stop right here on the USS Hornet. So our first journey through time starts a really, really long time ago. So long ago that life on Earth was just beginning to form. And see, I'm a geologist, so I use the information that rocks give me to try to unravel the history of the Earth, to understand what was happening where and when, and what were all the forces at play. And what does that mean is under there, under the ground, right now, where we can't see. And, I think about, was it a desert? Was it an ocean? How long was it that way? Was it an ocean long enough, and with the right conditions, to deposit a rock formation called banded iron? Because we're going to need a past where a lot of banded iron got deposited. And to find out, let's wait until our next stop in time. So after our next stop in time. So let's now jump forward about 2 billion years to 1942. And that's when the USS Hornet was being constructed. Now there are experts all over the ship about the construction and history of the ship, and I hope you'll take full advantage of the wonderful docents. We got an amazing tour yesterday from Ron and from Chuck with terrific personal history as well as ship's history, and we were so grateful for that experience. And so we're building the USS Hornet in 1942, and you'll learn all about that here on the ship. So I'm going to tell you just a little bit different story about what it was like to build ships for the war effort in World War II. So at that time, my grandfather was an engineer working in the steel industry, and he got transferred right here to San Francisco, where he and my grandmother and my dad were set up with an apartment in the Clift Hotel, which is still standing today. And he worked on the redesign of ships that were taking supplies from the US to Europe. They were called the Liberty ships, and they had a bad habit of sinking. So sometimes it was because they were easy targets for German submarines called U-boats, and other times it was because they cracked apart in the cold waters where they had to go to try to avoid the German U-boats. This was a really big, expensive, and time-consuming problem, and so two things resulted. One, there was a groundbreaking materials science study investigation done by a pioneering scientist named Constance Tipper, and then her work led to the structural redesign of the Liberty ships that my grandfather worked on. So the family story goes like this. My grandfather identified a key flaw in this emerging design that was being created, and he took it straight to the military leader in charge, ostensibly an admiral, and it was really bad news, and the admiral did not like it. He said, "If you show this report to anybody, I'll have you court-martialed." And my grandfather said, "Well, you can't court-martial me because I'm a civilian," to which the admiral responded, "Well then, I'll have you shot." So that's what it was like building ships for the war effort during World War II. In the end, nobody shot my grandfather, but the new Liberty ships were built with one mast house instead of two, and that was my grandfather's work. And in that same redesign, they changed the decks. The decks out here are wood, and on the Liberty ships, they changed them to steel. And that gets us back to the question, what does an ancient ocean have to do with building ships in World War II? So to find out, let's travel another 49 years from 1942 to 1991. I thought this crowd would get that. Okay, all right, so 1991. The USS Hornet was being decommissioned at that time, and it was going to be dismembered and sold off for scrap. But a museum in Canada filled out the paperwork for this U.S. ship to qualify for the U.S. National Register of Historic Places. And that's part of what saved the ship. So thanks, Canada. And so naturally, the U.S. Register of Historic Places is used to dealing with old buildings. So on the form, it asks, what's the building made of? So here's the description for the USS Hornet. Foundation, steel. Walls, steel. Roof, steel. And oh, by the way, this hangar deck has steel armor 1.5 inches thick. It was already made of steel, and they gave it steel armor. So that's why we need an ancient ocean that deposited lots of banded iron. Because to make steel, you need iron. And to make this ship, you need steel that's made from iron. And to complete the Apollo 11 mission, you need this ship that's made from steel, that's made from iron. So now let's jump ahead to the future of space, the legacy of Apollo 11. And there's currently under construction a towering rocket ship called Starship. And I don't know what year it's going to be, but that thing's going to land on the moon and then Mars. But the important thing is they're building it today, and they're making it out of steel. So that's our first little journey through time. And again, I want to highlight that there are many little journeys through time like that that you'll take on the tours here at the museum about navigation and communications and weaponry and the airplanes that are here. There are all kinds of little journeys through time that are like that one. But I only have one more to share with you today. So this one starts only a few thousand years ago. Now we're not going to go billions of years this time. And it starts with a guy named Archimedes. You might have heard of him. He's the guy in the bathtub who figured out that you could use displacement of water to measure volume. But what we don't learn in school is that he also invented the first propeller in about 200 BC. It's a really smart guy. So he didn't use his propeller to make boats go. He used it to bail them out and to move water in other ways. It was a few short millennia later when people finally figured out that they could use propellers for boat propulsion. And so about the specifications for the USS Hornet propulsion: 4 geared steam turbines, 4 screw propellers. So about 100 years after 1802, when they started using propellers for propulsion, screw propellers in particular were giving the Wright brothers a hard time. They couldn't figure out why their propellers weren't working. Screw propellers work like a screw or like a drill bit, advancing through an incompressible medium. Airplane propellers, it turns out, and as the Wright brothers finally figured out, have to work more like a wing or a sail. So that's called an airfoil. And that's one of the insights that propelled the Wright brothers to success in their first flight. But what about propulsion in space? There's no water to drill. There's no air to foil. You're on the move with nothing to change your velocity or direction. And you really only have a couple of choices. One, you can use gravity, which requires having the right massive body at the right place relative to you at the right time, and that's often done. Or, to move forward, you can throw stuff out the back. So, modern spacecraft and satellites use special propulsion systems that essentially shoot stuff out the back. You know, ions, plasma, Archimedes, come on, he would have loved that, right? So the Apollo 11 astronauts used both gravity and shooting stuff out the back to get all the way to the moon and back, and the helicopter that lifted them from the sea used airfoils, and the USS Hornet brought them home under the power of 4 enormous steel screw propellers. We can be there at every step of the way in the evolution of propulsion when we use our minds to travel through time. And then we get to use our hands to make the future that we see. You get to have a turn at shaping the future too. You can start yesterday, you can start tomorrow, or you can start right now. All right, so now I want to bring up some friends who all do this for a living, and I'm very excited. Really, really special to bring them up here. They work they're industry experts, and they're in the trenches and have been doing this work for a long time, but they're at different points in their career, and so we're going to get a good cross-section here of our friends. So come on up. I want Hannah to come up first, and then I haven't done an order. All right. And toward the end here, I'm going to give you an opportunity to ask questions of our panel. So Hannah O'Brien is a scientist at NASA, and you can bring your chair up a little farther if you want to. She is in charge of the moon rocks at NASA. So she gets to choose, she curates the rocks, and then she gets to choose what rocks someone uses if they need to do research on the rocks. So they call her, and she sorts through what she has and what their objectives are, and determines which rocks that they should get. And so as the others come up on the stage, come on up, Tina, Brendan, and where'd Al go? There he is. Come on up, and Hannah's going to tell us a little bit about her incredible job. Here, I'll get you. Let's wait for them to speak. All right. So Hannah, why don't you go ahead?
Yeah, hi everyone. My name is Hannah O'Brien. I'm a lunar curation scientist at the Apollo Sample Laboratory at Johnson Space Center in Houston, Texas. All of the samples from the Apollo missions are kept in our lab. So the astronauts actually picked up these samples on the surface of the moon, and then ships like the USS Hornet for the Apollo 11 mission returned these samples.
Hold closer.
Oh, is that a little better? Okay. And then they were shipped directly to my lab at Johnson Space Center. 55 years later, we are still studying and learning new things from these samples. There are lunar scientists all over the world who want to study these rocks. And so a big part of my job is I help them select the best rocks for their research, and then I actually go into the lab, and with tools like hammers and chisels, I actually break the moon rocks and prepare them to be sent out for scientists to study. In order to protect these samples, we actually wear these head-to-toe coverings that we call bunny suits, and we take really special precautions to make sure that we are handling these samples with caution. There's really no comparable feeling to getting to hold a lunar sample in your hand. A lot of the samples that I work with are actually just as big, if not bigger, than my hands. So it's really cool to get to experience that history. We also get to work with astronauts, so my job is a lot of fun. I get to help train them on lunar geology. And we also do a lot of really cool world-class tours. So we've given tours to a variety of people, like government leaders like Kamala Harris, celebrities like Tom Hanks and Mr. Beast, and NASA employees like retired astronaut Scott Kelly. So it's a really cool job, and I'm grateful to be here, and I'm really excited about the future of lunar exploration, this event, and the upcoming Artemis missions as well.
Thank you so much, Hannah. All right, so Brendan Swanwick is an engineer who manages satellite missions. He oversees everything from designing spacecraft here on Earth all the way to launching them into outer space and deploying them from the launch vehicle. And speaking of launch, he's about to launch a podcast. So Brendan, you've already accomplished so much in a short time, so tell us a little bit about what you do.
Thank you, Lee, for the introduction, and I would like to say thank you to the USS Hornet. We get to do this panel on the largest surviving artifact of the Apollo missions. So pretty cool venue. As Lee said, my name is Brendan Swanwick. I work for Voyager Space as the title is Mission Manager. So taking satellites from their inception as an idea through the design phase, through the safety process, all the way up to launch, and then all the way up to deployment. We'll launch these rockets to tons of different orbits, and we'll do it on a ton of different vehicles. So think the SpaceX Falcon 9, the Northrop Cygnus and Antares, even most recently, the Firefly Flight 5 out at Vandenberg Space Force Base. We'll also deploy these satellites from the International Space Station. So we'll launch them up on what's called commercial resupply vehicles, and then once they're up there, they'll enter the pressurized volume of the space station, and then they'll get deployed off the side of the station into low Earth orbit. These satellites are doing a range of different sciences, anything from new propulsion techniques to testing new radars to even testing new materials and some robots, if there's any competitors listening today. And as Lee said, coming up later this month, I will be launching a podcast called Moonshot. which is part of my mission to talk more about commercial space and the international space landscape and why it's so important to get tuned in and care about what is most likely going to be our next trillion-dollar industry.
Thanks, Brendan. Tina Gator is the CEO of a company that makes small satellites. And before that, she was the president of a company that makes space lasers. But don't worry, she's not an evil genius. In fact, she uses all that space technology for good, and she has spread that good all over the world. So, Tina, you've won major awards for your work, including Satellite Executive of the Year. Tell us about what you do.
Lee, thank you for having me to the USS Hornet Space Air and Space Museum. Thank you also for having me. I have chills being on this boat, and it is fantastic to hang out with the kids upstairs as well. So just a little bit about myself. I get to go have a lot of fun at work every day, leading a small satellite company. We design, build, and launch satellites. We have 8 of them up in lower Earth orbit. They tend to take some really cool pictures in different spectrum, optical kind of side of things, and we get to study the Earth. But we can actually put anything. Think of a satellite as being a bus that carries some really important people / payloads, as we call them, right? And those payloads can look up into the sky and look further afield, or look down to the Earth and help us learn a little bit more about Earth. I am an aerospace engineer by education. I like to say there's always smarter rocket scientists in the room than I am. I get to work with fun people like Al in the industry. Al and I see each other more at these kinds of events than we live here in the Bay Area, but never run into Al locally. And I hope to recruit people like Brendan to my company before Al gets there. Brendan gets to work with friends of mine like Clay, who's at Voyager Space now. So this is exciting. And my personal goal is to really pay forward what I've been able to amass in terms of knowledge, in terms of connections in the industry. As a young girl growing up in Kenya in Africa, I could only live on dreams of going to space. I wanted to be an astronaut. At 12, I moved to England to study. And I emigrated to the United States over 25 years ago, and this is where I've had most of my career. And when I look at space, or the aerospace industry, I look at it with a very global viewpoint, and this is kind of what I want to do going forward, is to really pay it forward to the young folks out there. And I always say this in professional circles, that if there's a billionaire out there, I'm happy to volunteer as a payload to go to Mars, to the moon, anywhere else. I'm cool with it.
Oh, wonderful, Tina. So Al Tadros is an evil genius. No, he's not. I'm just kidding. So he has led our industry for a long time and helped advance all kinds of technologies. In fact, he's an engineer who has done so many cool things that he's now in charge of lots of other engineers. And he helps to decide what problems need to be solved and then how to go about solving them. He also knows a lot about robotics and was really excited about the competition going on today. So Al, thanks for being here.
Thank you, Lee, and thank you everybody for coming. This is a really exciting venue, as was mentioned. I think this is my 4th time here, and learn something every time, but just seeing and being on it is exciting. So I'm Chief Technology Officer at a company called Redwire. We're very fortunate to be working on a number of technologies that go into space, everything from navigation sensors and avionics to this solar arrays that you might have seen on the space station. If anybody has watched the new solar arrays being deployed on the space station, So we get to work on a lot of very cool things. One of them that you might have seen recently that went around the moon on the Artemis 1 mission is the cameras. So if you saw the pictures of the Orion capsule with the moon and Earth in the background, those were some of our cameras that we built for the Orion program. A lot of really cool technologies. We also build some very unique missions. And I'm just going to tease you with a couple of things that you might want to think about or ask about later. First, as we go back to the moon, we have to think about how do we sustain our presence at the moon. There aren't roads, there aren't buildings, and we have to build infrastructure. So we're working on a technology that actually takes the lunar regolith, or the soil on the moon, and creates solid surfaces. Think about it like concrete blocks or paved surfaces, so that we can make landing pads and roads and foundations for habitats. So that's a really cool technology that we're getting to develop. Another one, which after 35 years in the industry, I had never worked or thought about, and I'm working on now, is air-breathing satellites. Now, you might want to think about that for a minute. They are orbiting, and they are going through the edge of our atmosphere, and they are using the edge of the atmosphere molecules or plasma, and I can talk more about that, but these are really cool technologies, so whether you're a technologist or an astronaut or anything in between, it's an amazing industry, and hopefully we can have discussion about some of these. Thanks.
That's great. Well, keep the microphone. Next, let's talk about Apollo and our inspirations, right? So the Apollo 11 mission is famous for inspiring a whole generation of space technologists and other kinds of space professionals. And so, you know, how in the world, these are incredible positions that you have, how in the world did you get where you are from just having an inspiration? And Al, I do want to start with you because I've heard you have a great story about your moment of inspiration.
So I was born in '66, but I was actually not born in the United States. I was born in Cairo, Egypt. And I think a lot of people who live here know Apollo and know that it's been inspirational, but might not realize that it was inspirational globally. This was not just a US thing, this was a humanity going to the moon thing. So the early years of Apollo, I was in Cairo, Egypt. I moved in 1971 to the United States, and I remember still on a black and white TV the last landing in '72 on the moon, and that was some of the earliest memories I have of being here in the United States. It wasn't until later, as I went into high school and then in college, that I actually was inspired by the space shuttle to go into aerospace engineering. I never really wanted to be an astronaut so much as there was just some really cool technical problems that space was posing to engineers, and I really was inspired by them. Some of the papers that I read during high school were from professors at MIT, and I got the privilege of going there for college and ended up working just about 12 years after the last Apollo mission with some of the GNC engineers that worked on the Apollo mission and formed Draper Lab. So the legacy continued well since then, but to work with some of the early innovators in GNC and navigation, which is what I focused on, was pretty inspirational.
That's great. I'd love to talk sometime about how you found and followed those papers. It's a big task. Hannah, you didn't see the moon landing, but you're a total Apollo nerd anyway. So what do you love about it, and how did you get into this business?
Yeah, so I guess kind of to start out is when I was a teenager, I used to go on these like late night moonlit runs, and I would just look up at the moon and be amazed by how beautiful it was. But I grew up in Chicago, Illinois, and in high school I had no idea that planetary geology or lunar science was even really a field that you could get into. And so it wasn't until I went to college at Notre Dame, and I took this really cool class with a professor who would eventually become my mentor, Clive Neal, that was called Planet Earth. And in this class, he had a section on the moon and lunar geology, and I was just absolutely inspired. And one of my favorite, I guess, Apollo-era stories that he shared with me was he remembers, on July 16th, 1969, being woken up by his dad at dawn to watch the Apollo launch, Apollo 11 launch. And he has always described it to me as his Apollo moment. And for me, that was just so inspiring. And so I actually joined his research group, and I started doing work at Johnson Space Center as an intern. And I did research that kind of covered the origin of the moon, the formation of water on the moon. And now I actually do research that is studying the resources that you could potentially find on the moon and how those will enable us to explore the moon, but also go beyond to Mars and the outer solar system. And with the upcoming Artemis missions, which will put the first woman and the first person of color on the moon, I am so hopeful that each and every one of you will have your own Artemis moment.
That's great. Tina, I haven't heard your inspiration moment until a little tidbit of it earlier. Tell us a little bit about how you got from that moment to where you are today.
So
They just offered you a CEO position right off the bat, right?
Of course, I was born a CEO. Come on. No. So as Al and I guess, both from the African continent and our immigrants here in the United States. So it was tough as a kid. I was always the odd one out, stargazing. And when you're a middle child of 5 and a girl, and are running around with your dad on small airplanes in remote places in Africa trying to build schools and hospitals. So engineering was my thing, I guess, from early on. But moving to England is when I discovered, books that I could read about the topic, read about the Apollo program. But in my secondary school, high school age, this was the era of the space shuttle program. So at that point, that was kind of how do I map my 14-year-old career to become an astronaut, right? That was my mission in life. And the inspiration from the Apollo astronauts, the astronauts on the shuttle program, I would find every opportunity to find out what it would take. And this is how it was classified to me. You're either going to need to be a fighter pilot or a scientist, and I was neither, right? I'm an engineer. I like to play with my hands. I'm not a scientist. And how was I going to become a fighter pilot in the UK? So I thought, all right, before I go to college, maybe I could go and join the UK Air Force. So tried out. I was in the OTC equivalent. Show up there, I'm like, college was free, so it wasn't like they were paying for my college. And then, during the recruiting process, they tell me, you're a woman, you can't fly fighter pilot. You can't be a fighter pilot. You can fly a tanker and go fuel someone. I don't want to do that. Oh, I want to be a fighter pilot. So that was kind of, all right, that's not going to work. I better start building stuff that goes to space. And this is kind of where I ended up getting into the satellite industry, choosing aerospace engineering, specializing in satellite systems. I had opportunities to work at Caltech to design and build a small satellite. It's a SURF program. SURFSat was up there doing great. And then just navigated my career around the satellite industry from different, whether it's trying to build smaller satellites, infrastructure that will get you and I into space, communication systems that let you and I communicate on the ground here. So those are, I call those enabling infrastructure technologies that help us on Earth, but are preparing us to be able to communicate and have not these delayed communications with our astronauts during the Apollo mission from the moon. Now we can use laser communication to move data faster. We can sell probes to the moon, smaller ones with great different technologies on the material front. So my inspiration really started with seeing others do some amazing engineering work. If you look at that capsule over there, if you think about that and Dragon today, it kind of look the same. There's a few cool electronics on Dragon, but the shape's the same. If you peel off some of those panels, Dragon's going to look pretty much like that capsule over there. So inspiration to me came from seeing other products out there like this.
Fantastic. Brendan, you spend some of your time working to inspire others. Tell us about your inspiration.
Sure. So in my undergraduate at University of Delaware, I chose biomedical engineering. Didn't know if I wanted to be a doctor or an engineer. I didn't really know what I wanted to do, period. I always had an interest in space, but I never really realized that this is something you can do as a career unless you're an astronaut. That was my perspective. You got to be an astronaut or else it's a dream. My second year of college, I started to read a little bit more. I was like, oh, this is pretty interesting. And I grew very fond of the development of the James Webb Space Telescope. And for those that aren't familiar with the James Webb, this telescope operates 1 million miles away from Earth, orbits at Lagrange point 2 specifically. It's the size of a tennis court when it's fully deployed. And in order to deploy it, there was 500 single points of failure. So 500 different ways that this thing could fail and be done. And then billions and billions of dollars are down the drain. But it didn't. It deployed, and it works, and now it's creating science that are actually questioning the laws of physics that have governed us for centuries. And that really struck me. I was like, wow, how did they manage to get this thing to work? And turns out there's a team of thousands of engineers that worked over a decade to make this thing happen down here on Earth. So knowing that, and knowing that there are opportunities down here, I took a stroke of luck and just started the only place I knew, nasa.gov, and just started applying to internships. Dozens and dozens and dozens, probably not qualified for 4/5 of them, all of them. But I landed one, and it wasn't necessarily the coolest job in the world. It's not something I wanted to do for my entire career, but it did give me the opportunity to realize I can really do this. I can get into this, and I think that was the biggest stepping stone that I had to get to where I am now. And because of that, I was able to work with people to develop commercial space stations, and now I get to launch satellites, which we talked about previously. And is a really big reason why I wanted to start this podcast, and Lee gave me the opportunity to come here and chat with you guys about why it's so important to have that moment where you realize that you can do this too. So hopefully you all don't have to come to that realization through a brute force of blunt applications, and it really is important to care and find what fulfills you with this industry.
That's great. Now, in just a minute, we're going to take your questions from the audience, but I want to talk a little bit about the present and future of space, so we're going to combine those two discussions. And I want to ask, just start with Brendan, what does the future look like to you? What does the present look like to you? And what are some of those key exciting challenges that you want to talk about? And then hopefully we can have a little bit of discussion with the panel. Just jump in. Yeah.
Sure. The thing I find most cool about space today is comparing it to space yesterday, space a year ago, and space 10 years ago. 2023 alone, the United States commercial industry launched 117 rockets. The world in total launched, I think, over 2,600 objects, so payloads, rockets, satellites, you name it, to orbit. And 81% of those was the United States. So it is absolutely exploding, and I think one of the interesting relationships that has sprung up in the last decade is the role of NASA and the role of the commercial industry, with NASA bringing on these exciting opportunities and financial backing, with an engine technically in building these projects.
Anyone else want to jump in on that?
So, Brenda, you make a really good point. I think early on in my career, in many of us, NASA has been a huge inspiration, a fuel, an engine to innovation. The gentleman over there was just telling me about the cool microwave they had in the Airstream. If you haven't heard that story, go talk to him. That's how we all enjoy microwaves at home. NASA came up with microwaves, right? So the astronauts coming off of Apollo 11 were nuking their food with microwaves. That's how they were eating warm food. But where are we going next? It is incredible how much commercial space industry is now moving things so much faster than, and are not necessarily relying on government entities to fund and to fuel some of that innovation. and the US companies, global companies, startups out there. So, you know, I did many applications to nasa.gov too, never got accepted. But, you know, there was a Boeing company that hired me, and that's how I started my career. But there are small companies, my message is there are small companies that are innovating at a faster pace, and you don't have to be an aerospace engineer or materials engineer. You can have a business degree, you can have a political science degree, and still want to be part of the space industry. Today, it's about how to innovate really fast, how to create what they call MVPs, minimum viable products, and just getting them out there, because Al can speak to this even better in terms of the technology cycles have just increased, that they're so fast now. The chip industry is coming up with really powerful computers, and you know, we're talking about putting satellites that do edge compute up there, or moving data via laser comm, or using water for propulsion. There's so many innovations that don't necessarily come out of institutions and agencies. So there are dreamers in the commercial industry that were inspired by the government agencies like NASA and ESA and JAXA. My country, where I was born, Kenya, now has a space agency. Wow! I would have never thought about that. But there's a lot of innovation happening, right, Al?
Yeah, absolutely. Actually, if you're not from the space community, you might not realize right now is the most exciting time ever, and I'll say that here on the Hornet, ever in the space industry for a number of reasons. If you love going to the moon and want to go to the moon, plenty of opportunities to work on the rockets or the spaceships or the lunar surface infrastructure, but we're also building the next generation space stations around low Earth orbit or in Earth orbit. So if you love human presence in low Earth orbit, there's plenty to do and multiple companies working on that. There are commercial satellites that are financed by private companies going on right here in Silicon Valley and around the US. There's also a lot going on for deep space and science and exploration. The US has a tremendous amount of budget going into that. Everything from suborbital launch to deep space and cislunar or between Earth and the Moon, there's a tremendous amount of work going on. There's one area even that I will mention that you might not think about, which is microgravity research. So this isn't technology for space, but this is performing research in space to bring products back to the Earth. So we're fortunate in working on bioprinting, using human tissue printing in space in order to bring back things like knee meniscus or heart tissue back to Earth. And the benefit of doing that is using the microgravity environment where you don't have buoyancy and you actually can create 3D structures without having any gravity effects. So I will pose to you that there isn't a single field of study that isn't needed in space. In fact, if you're a lawyer or a scientist or an engineer or technician, vocational skills is all used in space. So if anybody thinks that, hey, I know something that can't be in space, let me know. I'd love to have that challenge.
Yeah, and I'd love to expand a little bit on what Tina and Al just said is, like Brendan mentioned, you thought at one point that you had to be an astronaut to work at NASA, right? And I think a lot of people have this misconception, but we have scientists, we have engineers, we have geologists, but beyond those technical roles, we also have folks in our business office who have business degrees, finance people. We have NASA TV, so folks who, want to be anchors or actors and kind of communicate the science that's happening. Regardless of what you're passionate about, we have space for you, and we want you. We need you to be a part of the Artemis generation, because as amazing as it is to celebrate Apollo and the incredible history like we're experiencing on this ship, there really is a huge need right now for our generation, for the future generations, to step up and step into these roles. So don't be afraid to take that leap.
Very nice, very nice. All right. So for these last few minutes, that was beautiful. I want to open the floor to questions. I see some familiar faces. I appreciate everyone who came. Are there any questions from the audience? Yes, Sam.
Anyone on the panel, you see all of the brilliant creative robotics like that.
Yeah, so I'll repeat the question so that it's recorded. He's asking, with all the amazing robotics work that's being done upstairs, along with at many companies and at government agencies, why would we ever need to send another human to space? And so I'll let the panelists jump in.
You can't put a price tag on dreams. You have to have humans go out and have the dreams and innovate. I often have this conversation with people who are wondering why we spend billions in human spaceflight, where we can send a bunch of robots to explore. And I don't think it's an either-or situation. I think, you need both. If humanity isn't able to explore and dream, and Archimedes in his tub, or Vasco da Gama discovering, the United States, there's exploration to be done. Robots are great, and we make great robots globally. But I think getting back to the moon or going to Mars is going to create so much more inspiration for the next several decades and there could be another version of USS Hornet, but it could be, floating above the Earth, and somebody will be on there talking about, do you remember when? So for me, I think it's an essential part of our humanity to explore.
Yeah, I would definitely agree with that. And I think, beyond just the fostering and maintenance of dreams, is there's really no substitute for real-time human decision-making. The surface of the moon is a very harsh environment, and while robotics continues to be, an ever-growing field and they get better and better, there just still is no real substitute for the real live-time risk assessment that can be done by a person on the moon. Jack Schmitt was actually the first geologist to go to the moon during Apollo 17, and his ability as a geologist to see samples and select them based on his expertise, there's not a robot in the world, even today, that was 50 years ago, but even today, there's not a robot in the world that could do that. And so I think there's always going to be this essential human component.
I'd like to echo something that Tina said, and most of our innovation is fueled by human inspiration. So all the way back to the first wave of innovation back in the 18th century, where we mastered how to build textiles and sailboats, and now we're in the sixth wave of innovation. Starting in approximately 2020, we're focusing on robotics, automation, sustainability, and all of these are tools that complement humanity. And at the end of the day, the people that are making the big decisions, the people that are sitting on top to fund these different projects or start these different projects, at the end of the day, they're humans. And it's not a great inspirator if you fund all these projects and then you send a robot to the moon or a robot to Mars. The pictures that we remember from the Apollo era are the pictures of Neil Armstrong stepping onto the moon, or pictures of a selfie inside of a Crew Dragon vehicle. These are the ones that really impact the community and impact the world, and are the ones that are going to stir excitement for future programs, like the Artemis program, for example.
Yeah, I'll try to add to what was said, because I completely agree with that. But one of the things that might not be talked about as much is that there's a belief and demonstrated necessity to think about humanity as a multiplanetary species. So moving humans off the Earth and settling, whether it's orbiting habitats or other planetary surfaces, is a thought-provoking condition that I think some people are already deep into and working towards, but a lot of people don't realize that in this moment in time, and Lee talked about billions of years of history, is kind of the first moment in time where humans can actually consider going to another planetary surface. So the purpose of putting humans in space is multifaceted, and that is one angle that is really interesting to think about.
I think Elon Musk would love to have a beer over you over that comment.
Great. Any other questions? Yes.
First of all, I just want to say thank all of you for coming. There are probably better things you could be doing on a Saturday, but sitting up here and promoting your profession, you're all a credit to your profession. The other thing you're doing that is just awesome is you're an example to the folks that are here and the youngsters upstairs One little fella, love him. He didn't know what the on-deck circle was, but he can make a robot. So pretty pleased with that. I'm going to get a little serious here because you're all in the space industry, and if you are a space professional, you know the Challenger, you know Boeing, and you know CrowdStrike. My question for everybody here is about the culture of risk and risk mitigation in your professions, because you all sit up here, very successful people, but in your daily, and I spent an entire career dealing with risk and managing risk. I wanted you to talk to the audience here, because as we sit on an aircraft carrier, and you understand how an aircraft carrier works and the manifold things that have to happen right to launch aircraft and snag aircraft, space gives it a whole different, and based on Sam's comment about the human aspect, there's a very real risk mitigation factor to this. But thank you again.
I can start and make a couple comments on that. And yeah, I talked about the solar array that we deployed on the space station. That was, from an engineering perspective, phenomenal. But that was the first time in 35 years I've seen a deployed structure actually actuate next to a human being, an astronaut who just had installed it at its mounting point. And that's humbling to see, a tennis court-size solar array deploying near a human being that could easily be, injured if anything went wrong. I think there's two things. One is engineering practices and processes are, well proven, well implemented, well audited, quality control. Even with that, there's an underlying risk tolerance of the community that we have to consider. In Apollo days, many of the astronauts were test pilots, and their career was littered with challenges and risks that they understood and they took on, including the Apollo mission and the preceding missions. Nowadays, Challenger, Columbia, and others, it's more than a little gut punch for a lot of people to see people hurt, and so the risk tolerance is changed dramatically over the past 5 decades, and heading more. Unfortunately, we do have the reality that it is a high-risk proposition to put astronauts on the surface of the moon. Some of it, I would say, is completely out of our control, including micrometeorite impacts that we have to think about and design for. The moon looks the way it does because of billions of years of impacts that have been happening. No atmosphere to protect it, no magnetic field to protect it. It has radiation and meteor impacts. So some of it is just the reality of being in space, but some of it is good engineering practices that are there and we should be following. Some of it's in the news because of commercial aviation now, but I believe we are able to quantify and implement and execute as good engineering practices.
I'll echo what Al just said. So industry professionals, commercial companies, institutions, all working on products that humans have to interact with or live in space, or if I were to send a particular product, whether it's a laser comm terminal or deploy any kind of object that's going to be near a human being on the space station, there's a whole different qualification step required, right? There are some very stringent requirements when you're going to be using the product, living in a product, operating the product in space, whether human spaceflight. On the flip side, if you're launching satellites, there's been a trend now to say, let's launch them cheaper and faster. A real reason, because there's a different risk profile that some of us in the industry, and especially on the government side, we had a space race to go and do Apollo, That's where Apollo came from. There was a space race, right? The Russians were doing things, and Kennedy said, we're going to the moon, and we're going to do the Apollo. Well, we're facing a different race right now. It's called securing our country, securing our allies. And there are things going on in space where we have to be looking at, should we launch something faster? The Chinese certainly are. Brendan gave you some stats on rockets and satellites launched in the US. We are going to be swallowed by the amount of satellites and rockets that the Chinese are launching. So we have to take some risks to launch some of these satellites faster, because guess what's happening? They're launching satellites that have satellites inside of them that are coming really close to our satellites and are snooping at them and are wiping them out. They're ASATs. They're literally exploding and creating space junk, which is not cool because it's going to hit an object, a tiny little object in space, traveling really fast, can knock out space stations, can knock out our telecommunication satellites. So what the really smart engineers in most of our companies are doing are assessing risks in terms of the types of products we're launching, how fast we need to launch them, are taking into account if this is human space flight related. I mean, hats off to people who are creating the commercial space stations. Did you ever think there would be commercial space stations? I didn't. I mean, I got to tour on a Russian space station Mir module. My first job was space shuttle program. I got to work inside of an ISS module for a short period of time, all on the ground. I never thought I'd see the commercial space stations being talked about, and that's just in the last 10, 15 years. So risk is something we deal with every day, and a lot of us say space is hard and it's going to continue, but we have to take some risks.
I think what the question is similar to is, wow, the commercial space industry is growing so fast. But it's similar to a child running with scissors. It's, if you run too fast, then there's going to be an incident. And I think that's an interesting risk posture that each individual private company has to balance, especially when they're not backed by a government agency, which you were referring to. So some of the space, it's interesting you bring up the commercial space race, because there's some commercial space stations that are being built under a contract from NASA. For example, the Voyager Space Star Lab or the Axiom Station. But then there's other players in the game, like VAST, who's building Haven 1 and is all privately funded. So they have to develop their own risk posture to be able to send humans comfortably to their station. And I do totally sympathize with the fact that when our companies are moving fast, I think SpaceX is notorious for moving very fast, to have a very low aversion to risk, which can be dangerous, but it's also a risk that you have to take to move quickly. So there's always going to be a balance, and I think it's going to be more important the further we move into the future about how do we manage smaller companies that want to move fast and keep up with either their competition in the United States or their competition overseas.
And Hannah, we can't forget about the rewards, right? So in any discussion of risk, I think we like to talk about risk, we like to worry about risk, but we always need to remind ourselves we get space rocks. So this achieving, this attempting, even when we fail, even when it's dangerous, even when it breaks, I think is important. One last, we'll do two brief answers.
Speaking of reward, I'd like to know what can space exploration teach us about advancing the sustainability of our own planet?
Oh yeah. So sorry. She asked, how can space technology contribute to sustainability on Earth? Is that apt? Okay.
So I have a quick answer. I don't directly work with the company, but I believe in it. Interloon is developing a new way to mine regolith for something called helium-3. This is a very specific science answer for you. And helium-3 may have the capabilities to build neutron detectors. They'll also have the capabilities to build nuclear energy sites. without the impact of all the radioactive waste. But helium-3 is not present on Earth unless it's at a nuclear detonation site. It's only present potentially on the moon from solar winds. So that's just one example that we discovered actually from one of the early Apollo missions, one of their geologists, which I think you mentioned, that we're discovering these different ways that sustainability is widely impactful on Earth, and that's why we continue to push to find these new ways that we can bring that technology that we don't have on our planet down here.
Sustainability or just learning about the Earth by using space assets, that's what I've been focused on. So as we're launching as a commercial company different types of satellites that are imaging the Earth, it's not just about the cool photo on CNN that shows, a ship blocking the Suez Canal, but there's a great amount of science being done through small satellites where we're able to detect different types of gases, industry on the ground that are not following certain rules. So we're able to detect, methane, or we're able to detect, a lot of carbon. We're able to take imagery about people who are probably cutting down too much of the Amazon. There's a security aspect of things that are done by lower Earth orbit satellites that are taking pictures in different spectrum. And then there's a real sustainability aspect for things that happen on the ground. But now there are rules about sustainability in space as well, right? We can't just launch things and then have space junk. There are regulations now about deorbiting some of our satellites, right? Before it was like you could just let them fall out and then maybe they'll hit somebody. But now there's regulations that you must deorbit within 5 years, for example. And that's creating a burden on some commercial industries, because to deorbit, you can either use gravity and it'll just come down, or you have to carry enough fuel to deorbit, or you have to have solar sails to deorbit. There's different methods. So sustainability is being talked about in our industry as good citizens when we send things up into space, but then also using space infrastructure to continue to learn more about what we can do on the ground.
I think we'll go to the last question here. I think you were going to ask, yeah.
For the potential future innovators in the room, what are some of the technological challenges or perhaps unglamorous that we should be looking to address today?
Oh, great question. So the unglamorous technical problems, engineering problems that need to be solved.
I might have an answer for this one. So one of the big challenges of potentially living and working on the moon is lunar dust. And people don't think about that, when you think about the surface of the moon, but it's actually a huge challenge because these grains can be so sharp and so damaging, and there's no atmosphere to protect the moon, or people could potentially be on the moon from this dust. And it also is electrostatically charged, so it can be very sticky and hard to get off of things. And we're looking forward towards Artemis and reflecting on Apollo. This is a challenge that is not going anywhere anytime soon. And it's not necessarily fun to talk about, but we can't ignore it as an issue.
Yeah, so thanks for the question, because everybody sees the rockets and the sexy part of space. Unfortunately, there's a lot of unglamorous parts that don't get front page cover, including toilets. Toilets in space are notoriously problematic, and if you have a good solution for that, you're a millionaire right off yeah, make sure you tweet that out, that what you learned on the USS Hornet is that toilets are hard in space. Believe it or not, I think the Russians have us beat on the reliability of toilets in space right now. And I think you actually heard about it on the first commercial launch of Dragon. But there is plenty of, not front page news on technologies. There's no shortage of challenges. I believe that AI has the promise of solving a lot of challenges in space, from robotic assistance to simple emotional support for astronauts. You're confined in a room probably no bigger than your house, or smaller, for a long period of time, and that's if you're lucky. If you're in a capsule for missions, to the moon and back, it's even smaller. So there's emotional challenges for having humans in space that I think have technical solutions that are going to be coming along to it. There's plenty to deal with lunar regolith, surviving micrometeorite impacts, as I mentioned before, deadly kind of stuff that might not be the front page stuff. But I did want to touch on the fact that we are in space and we have conquered a lot of the hurdles of being in space has really improved the human condition. Our quality of life is dependent on space systems, from communication satellites to navigation satellites. I bet everybody here used some kind of Google Maps to find this ship today, because I don't know how you get through Alameda without it. Communications, weather, just knowing, weather forecasts, all of that is really driven by space systems that we depend on. And we touched on, but national security is kind of defined by whose superiority in space. So a lot of it is kind of dependent on us making sure that we have the challenges, the engineering and technical challenges addressed that are necessary to be in space.
Hey, just lastly, if you have some time, go look at websites like United States Space Force, Space Systems Command, or look at NRO's website, and it's really cool. They list out all these technologies of the future that they're looking, and industries like us, Lee's company, mine, Al, we look at these guys all the time and go, who is going to fund our next tech innovation? Because there are 60 different technologies on SSE's website that they're struggling to find companies to acquire some of this tech. So check out they're really telling you what they need in the next couple of decades. So many startups are fueling from that.
It's great. You can use your refrigerator magnets that are letters to make all those acronyms that you'll have to learn in reading those documents. Well, I would love to go on all day. I want to encourage you to take what you've heard today and do something about it, because the value of this conversation really lies in what you take away and do with it. So I really want to thank my esteemed panelists, colleagues, and to you all for coming and joining us, and especially to the USS Hornet Museum for having us here today in this beautiful venue that's historic, and the significance of it is just really wonderful, and we appreciate the invitation to come.
Thank you for having us.
Thank you all.